Industrialization and globalization are having huge environmental impact. Greenhouse gas and toxic emissions, waste disposal, and air, water, and soil pollution are causing ozone layer depletion, endangering ecosystems and clean water reserves. To address these problems, the life cycle assessment methodology can be particularly useful. This technique allows a quantitative analysis of the environmental burden of a product in a life cycle. This life cycle comprises all stages from the extraction of the raw materials to the manufacturing of the product, distribution, use, and final disposal in a cradle-to-grave system boundary. In this way, we can not only assess the life cycle contribution of a product on different impact categories, such as global warming, ozone depletion, water consumption, and human toxicity, we can also evaluate which of the stages of the life cycle is having the highest environmental impact. So let's say we want to conduct an LCA. There are 4 steps to the methodology. First, we would need to define our aim and scope. Suppose that we want to determine the CO2 emissions released in a cradle-to-gate life cycle of one Coca-Cola can. At this stage, we must consider the volume and the materials that compose the can. Also, we would need to establish where it is produced and the means of transport from the production plant to retailers. The second stage is the life cycle inventory. In this stage, we will collect all the data necessary for our analysis. The quantity of each material that is needed to produce the Coca-Cola can, the amount of energy and water and so on to create our flow model outlining all our inputs and outputs. Now we are ready to move to the third stage of LCA, Impact Assessment. Having our data, we can look at all the impact categories and choose the one that we are interested in, seeing how they are measured. We said previously that we wanted to determine the CO2 emissions, so we will look for the global warming potential. Finally, we are left with the interpretation of results. Considering that LCA is a complex analysis and the limitations of our assessment, we can draw conclusions. Whichever is the stage of the life cycle of the product that is having the biggest environmental impact, it can be improved. For instance, whether it is the resources extraction or the manufacturing that is having the biggest environmental burden, we should try and implement as many principles of green engineering as possible, such as choosing renewable materials and energy sources rather than depleting ones, or to prevent waste formation rather than treating it afterwards.
Created using Powtoon.